So for those of you who need proof um, that when we're dealing with three separate functions multiplying each other, and we need to find the derivative of it, that it is indeed f of x times g of x times the prime of h of x plus, and then you just repeat that, f of x, but this time it's the prime of g of x times the function h of x plus, and finally the last one, the prime of f of x times the function g of x times h of x. And by the way, that can be for multiple functions. You're essentially taking the prime of each one by one and multiplying it by the other functions and adding them all together. For proof of this, you just need to go back to the basics of the product rule. The product rule says f of x, and it's easy to prove, I have it in my chain rule proof, is equal to f of x times the prime of g of x plus g of x times the prime of f of x. This is very easy to prove, and all we need to know is multiple products. Well, I'm just going to shorten the products down, okay? I'm going to call the products u, v, w. And I need to prove that it is equal to this. U times v times w prime plus u times v prime times w plus u prime times v times w. Okay, let's start with just u times v. We know that u, or let's just take u times something called x, okay? We know that from the product rule that's going to be u times x prime plus u prime times x. Pretty simple, right? If these are two different functions, that's what they are. But now I'm going to say, wait, u doesn't equal, x doesn't equal x. X actually equals the product of v times w. The product of v times w. Which means wherever I see x, I have to put in v times w. Okay, that means it's not this. It is actually, get rid of this x, and in brackets, put v times w. So I've got to find v times w prime. And then over here, it's u prime, and then fortunately x is not taking the derivative here. I can just put in times v times w. No problem on the right here. This is already solved. I just need to figure out what the heck is the prime, what is the derivative of v times w. Well, that's just the product rule again. So it's going to be u times, open brackets, v times w prime plus v prime times w. That, the derivative of that is just the product rule again. If I distribute the u through there, I get u times v times w prime plus u times v prime times w, and then I just add on my box that's already done. U prime times v times w. So we can see that multiple products still follow the product rule. I've essentially proven it here. Multiple rule products still follow the product rule. You just, to prove it, you just got to treat two of the products like one function for now, follow the product rule, and then replace them. But this is true for any number of products. I can have c of x times g of x times f of x times L of x times n of x, and the derivative of this will simply be this, this. How many are there? There's 5 of them. 5 times. We're going to add them each time. Boom, boom, boom. And you've just got to take the derivative of each one at a time. And this will be the derivative of that. Nice thing about derivatives also, remember, you don't always have to add them all together. So long as you have a formula in there, you can now punch in your x value and just add up the numbers to figure out the value of the derivative of that. Sometimes that's all it takes. But it just goes to show that the product rule is very dynamic and can prove a lot of things. And I show this because I use the product rule to prove the chain rule.